Hey guys, we're going to be going over the Unit 2 practice test today. For the practice test, I'm just going to do one of the problems. I'll give you the answers to both of them, but I will actually work through one from each box and do my best to explain it. All right, number one. So I'll do this first one for you guys. All right, so what we're trying to do here is classify this polynomial by its degree and number of terms. So this is just some vocab stuff here. So to find the degree, what you're going to do is what you're looking for is the highest exponent. And sometimes you'll get these polynomials that have two variables being multiplied together, or I guess it could be more variables being multiplied together. But if that happens, what you're going to want to do is add up the exponents in each term. So here's a term, right? That's one thing that's being added together. We're going to want to add those. So 3 plus 5 is 8. And then here 6 plus 2 is 8. And 4 plus 4 is also 8. So it just so happens that our highest exponent in all of those terms is 8. So what we're gonna call this is an 8th degree. 8th. Is that how you spell 8th? That looks weird. I'm gonna just stick with that. 8th degree. And that's because 8 was our highest exponent. And now we need to classify it by the number of terms. So the number of terms, you just count the pieces of the polynomial. So the things that are being added or subtracted. So we have 1, 2, 3 terms. So when you are classifying a polynomial by its number of terms, you're either going to use one of 3 words, or I guess 4. A monomial would be a single term polynomial. A binomial would be a 2-term polynomial. A trinomial would be a 3-term polynomial. And then everything else we just call polynomials. But once again, this one has 3 terms, so we're going to call it a trinomial. And this one, we would call this a 4th degree binomial. All right, let's see, I'll explain the second one here for number 2. So for number 2, what this is asking us to do is simplify, which really just means kind of clean it up. If there are any like terms, let's combine them. And then once we've combined all of our like terms, we'll want to rearrange our polynomial so that it is in standard form, which means highest power to lowest power. So when you're simplifying polynomials, I like to start like this. I look for like terms. So I'll just start with this one. So this is b cubed. So now I'm going to go and look through my polynomial. Are there any other b cubes or b to the 3rd powers? So there's one. So I'm just putting 3 lines under it to show that those two are like terms. And now here we have b to the 1st power. So let me underline that. I'm going to go through my polynomial. And it doesn't look like there are any other b to the 1st powers. So this guy's going to be solo. And let's see, -6. I'll put dots there for that one. So this is just a constant. So now I'm looking for any other constants in this expression. Here's one. And then all we have left is b squared and b to the 5th, which those are not like terms. So let me actually erase this one. So I just created little symbols to show the like terms. And now what I'll want to do is combine them, meaning add. So this is like I've got -3b cubed, and then I'm adding a -8b cubed. So that's going to put me at negative 11b cubed. 2b didn't have anything to combine it with, so I'll just keep it there. And then I have a negative 6 that I'm combining with a negative 9, which that's going to get me to negative 15. I could have written minus 15 here, but instead I wrote plus negative 15. That's going to help us later when we go to rearrange this. So for these types of problems, subtraction's not your friend. Let's use addition if we can. And then we have plus negative 8b squared, then plus 7b to the 5th. Nothing to combine those guys with. So now when we write it in standard form, we need to order it from the highest power to the lowest power. So 5th is my highest power, so I'm going to write that first. 7b to the 5th. Then looks like third power is my next highest power. And then we've got a squared. And then we have b to the first power. And then we have the constant. Now, all these places where I have plus a negative, you could change those back to subtraction if you want, but I kind of like it like that. And the answer to this one was 3x squared plus 13x minus 4. All right, number 3. So now we're adding polynomials, which is actually exactly the same as problem 2. It's just these polynomials are in parentheses, but it's the exact same concept. So you could use this method that I did before where you create symbols for like terms and just put them together. Or you can also stack them up vertically and add them that way. So let's see, I'll do this bottom one for you guys. So when I stack this up vertically, I'm basically just going to take this polynomial here and write it underneath it. And I want to make sure that when I write it underneath my other polynomial, that I'm lining up my like terms vertically. So here's x cubed, so I want to make sure that this is 6x cubed is right underneath the 12x cubed. And then I'll put the 9x squared under the negative 8x squared. And then negative 7 and negative x aren't like terms. So we want to be careful there. Let's not add those together. Maybe I'll kind of put the negative x out on its own here so we don't get confused with that. So now when I add these together, I'm going to do negative 12x cubed plus 6x cubed. That's like I'm $12 in debt, and then I find $6 or something. I'll go give those $6 to the person that I owe money to, but I'll still owe them more money. So I'm going to have negative 6x cubed. And then negative 8x squared plus 9x squared. That's like I owe somebody $8, but then I find $9. I'll pay off my entire debt there, and I'll be left with 1x squared. So $1 in my pocket. And then negative 7 plus 0. And then 0 plus negative x. So those guys are just kind of hanging out on their own. And then last thing we want to think about, is there any simplification? Oh no, we did the adding, so there's no simplification, but we can write it in standard form. So standard form, all we're going to have to do here is flip these last terms. Once again, that's kind of why addition is our friend here. And let's see, the answer for the other one was 6x cubed plus 4x plus 1. All right, number 4, we're subtracting. So subtracting, really similar to adding. We're still just trying to put our like terms together. So you have two options here. You can stack them vertically and subtract, kind of like we did in the last problem. Or I'm going to show you the other method here, and looks like I'll do this one for you guys, the bottom one. So the other thing you can do is essentially you're just going to take this minus sign and you're going to distribute it to all of the terms in the polynomial that follows it. So I'm going to take this minus sign and I'm going to distribute it to all of those guys. And I guess let me show you what's going on there. So another way to think about it, change subtraction to addition, and then make what follows it a negative. But really, we could put a 1 in front of it. So this is like, it's kind of like a -1 that we're distributing to all of those things. Not sure how helpful that is, but that's really what you're doing. So we do -1 times 4x squared, -1 times 44x, and -1 times 9. And when you multiply something by -1, it's just going to flip the sign of the thing that you're multiplying it to. So here I have a positive 4x squared. So now I will have a -4x squared. And then we had a positive 44x, so I'll have a -44x. And -1 times 9 is -9. So now I suppose I could still align everything vertically and add it, or I could create my symbols and combine like terms. I think I'm going to do it that way this time. So I am going to start with my x squared. I'm going to see if there are any other x squareds out there. It looks like there's one in my other trinomial. And then I've got x to the first power. Let's see if we got any x to the first powers out there. There's one in this trinomial. And then I've got two constants. So I figured out all my like terms. Now I'll just put them together. So -8x squared plus -4x squared. So we're combining a positive 8 and a -4. Just going to get us to 4x squared. And then we've got a 15x, a positive 15 that we're combining with a -44. So that's going to bring us to -29x. And then the last one, combine our constants, 28 and -9. Bring us to +19. And then last thing we'll want to do is just make sure that this is in standard form, meaning highest power to lowest power. X squared, x to the first, constant, we're good. And the answer to the other one up here is 6x squared minus 19. All right, so I'm going to stop this video. We'll pick up the backside in part 2. All right, guys. Unit 2 practice test, part 2. So once again, I will do one of these problems, try to walk you through it, and then I'll just give you the answer for the other one. All right, number 5. So we are trying to multiply the monomial 4x to the trinomial 3x squared plus 8x minus 2. So to do this, what we're going to want to do is we're going to want to distribute 4x to each term in the trinomial. So we'll have 4x times 3x squared plus 4x times 8x plus 4x times -2. And so now we're just going to multiply all these monomials together. So this is 4 times x times 3 times x squared. So what we're going to do here is we're going to end up multiplying our coefficients, 4 and 3, and then adding our exponents. So 4 times 3 is 12, and then we have x to the first and x squared. You add 1 and 2, and you get 3. And 4 times 8 is 32, and then we have x to the first and x to the first, so you add 1 and 1, and you get 2. So this will be 32x squared. And this last one, we're going to do, let's see, 4x times -2. So you're just going to multiply -2 to 4. So now that we have distributed and simplified, we will want to just confirm that we have this in standard form. Highest power to lowest power, cubed, squared, first should be good. Second problem is going to be -15x to the 7th.
Hi, it's Mr. Garcia here. I'm going to jump in and do some problems. All right, number 6, multiply the binomials. Write your answer in standard form. So we're going to do one FOIL, one box. All right, if you remember, FOIL is an acronym for the order of which we multiply these terms. So F is for first. So we're going to multiply x times x. You can write in some coefficients too. So 1x times 1x. Then we can move on to the outer terms for the O. So I'll just put plus between all of these, and we have 1x times 5. Then the I is for inner, so we can multiply 3 and x together. And then the last terms here, L is for last, 3 times 5 are going to be my number terms. So plus 3 times 5. And now if we go and multiply each of these monomial multiplications independent of one another, we will have a sum of all of these. So 1x times 1x is just 1x squared. 1x times 5 is 5x. 3 times x is 3x. And 3 times 5 is 15. Now we check to see if we have any like terms. And we do. The middle terms, 5x and 3x, add up to 8x. All right, so I'm just going to write out my final answer. The two sum here is 8x, and then we have x squared. You can drop the coefficient if you like, and then 15. And this will be my final answer. All right, the second problem here, I'm actually going to build a box of dimensions 2 by 2. And along the top, I'm going to put my first binomial, so 1x and 6. Along the side, I'll have 1x, -7. And then I'm going to go ahead and multiply all the rows and the columns together. So 1x times 1x is 1x squared. 1x times 6 is 6x. -7 times 1x is -7x. -7 times 6 is -42. Now I check to see if I have any like terms. So along the diagonals, here I have -7x to 6x, which add up to -1x. All right. And last thing to do is everything's a sum. All right, so my final answer is x squared minus 1x minus 42. All right, here's some more multiplications of binomials. Again, I'll do a FOIL and a box. That's a FOIL. I'll multiply the first terms together, 3x times 4x. And I'll always add a sum in between these two. And I'll take care of the sign after I multiply. So the outer terms are 3x times negative 7. The inner terms are negative 8 plus 4x, or times 4x. And the last terms are negative 8 times negative 7. All right, 3x times 4x is equal to 12x squared. 3x times negative 7 is negative 21x. Negative 8 times 4x is negative 32x. And negative 8 times negative 7 is plus 56. I see I have two middle terms in the middle, the blue and the red. All right, and those will add up to a number that is more negative. Okay, so 2 and 1 make 3, and 3 and 2 make 5. So 53 negative, and then plus 56. And this should be my answer. All right, last one, we have a box of dimensions 2 by 2. We'll put the first terms along the top, 4x and 1 and 3x, negative 5 along the side. Multiply the rows and the columns, so 3 times 4, x is 12x squared, and then 3x times 1 is 3x. Negative 5 times 4x is negative 20x. Negative 5 times 1 is negative 5. All right, check to see if we have like terms along the diagonals. Yes, these two add up to negative 17x. And so my final answer is everything's a sum of the boxes 12x squared minus 17x minus 5.
All right, number 8, we're talking about the special product formulas. So this one looks like we have a perfect square trinomial, and this one is the difference of squares. I'll go over the perfect square trinomial one with you. So the perfect square trinomial formula is a squared plus 2ab plus b squared. So I'm going to start by labeling my a and my b. So my a is going to be 2x, my b is going to be 5. So what I'm going to do is I'm just going to fill in this formula. Anytime that I see an a, I'm going to write 2x, and I'm going to put that in parentheses. Anytime I see a b, I'm going to write 5, and I'm going to put that in parentheses. All right, so we'll do 2x squared plus 2, that comes with the formula, so we're always going to have this 2. And we're going to multiply that by a, which is 2x. We're going to multiply that by b, which is 5. Then we'll add our b squared. Okay. So 2x squared, maybe let's write this out. We'll So we're going to do 2x squared. What that means is 2x times 2x. And then for this next one, 2 times 2x times 5. All of these things are being multiplied together. So we actually have like 3 numbers that we need to multiply. So for this one, I'm just going to kind of reorganize my multiplication. So I'll write this as 2 times 5 times x. Just kind of grouped up all my numbers to make them easier to multiply. And this one means 5 times 5. So 2x times 2x, we're going to do 2 times 2, which is 4, and then x to the first times x to the first. That will give us 4x squared. 2 times 2 is 4. 4 times 5 is 20. And 5 times 5 is 25. And the last one here, your answer is going to be y squared minus 25. You can use a different formula here. This one formula is just a squared minus b squared for the difference of squares. That is all. See ya.